chances are it's going to use ATP that is made from other sources than glucose. It'll be made from sources such as fatty acids. Alright? But when muscles are at use, they really need the quick source, which is the glucose. Okay? But chances are it doesn't need glucose all the time. You pretty much have to be an Olympic athlete to be able to eat all the sugar you want. Alright? Because then they probably don't eat it. Just a little bit. When we talk about contraction, one of the interesting things about muscle contraction, the way it happens, the fact that we've got to have the ATP, one of the things that is of interest is rigor mortis. Now, y'all heard me say this the other day, sitting up with the dead, and the dead sit up with you. And when death occurs, all right, death occurs because of one thing only. The heart stops. There are things that can lead up to that, but the eventual cause of death, the heart stops. That means blood flow stops. Oxygen carrying abilities stop. However, in skeletal muscles, the contracting of skeletal muscle does not stop until all of the ATP is depleted and calcium is no longer being released from the sarcoplasmic reticulum. And therefore, because those two things are important in that myosin head attaching to the actin, which means it pulls, which makes a contraction, whatever point all of that is depleted out of the body is the point that the body will be at the time of true death. So that means they could be sitting up, they could have a leg thrown up, an arm could be thrown over somewhere. There's many ways that those muscles could be when that death is occurring, all right? And before they learn how to really deal with this problem and transporting bodies and stuff like that, the dead would literally sit up with people. Because sometimes their bodies, the way it would end up in contraction would be them sitting up. When you see a body in a casket, that is not how they die. Okay? Their eyes are being closed with hooks. Their mouths are being closed with hooks. Bones have been broken so that they can be placed into the casket. Trust me, that is not how their death took place. Okay? So it's really kind of cool the things that go on for a morning. Basically, the depletion of that ATP. ATP is the immediate energy source. However, it doesn't have to be the only source of energy for muscle contraction. We have something called creatine phosphate. Ever heard of this one? Okay, and I know why you've heard of it. Because there are supplements out there that are creatinine. Okay? And they basically are being touted to us as a source for energy. Because in normal processes, when we begin to perform an activity, okay, y'all know I don't run, okay? But let's say I decided to do my warm-up, okay? And then I'm going to go outside and I'm going to start a run. Okay? Now, I'm probably going to make it from here to that wall. Alright? But somebody who's used to being a runner is going to have a totally different makeup in their body. Okay? They're going to be able to use in their cells the creatine phosphate that's available. It will be used during the first few seconds of that strenuous activity. When you are performing a strenuous activity, such as running, okay, think about this. You do your warm-up, and you start out running, and then you're going, alright? But after about 2 to 3 minutes, you can stride. Struggle's not as real anymore, okay? In between the point that you start to the point that you are in your stride, your body had to go through creatine phosphate and anaerobic respiration. It had to supply energy in the form of the ATPs by one of those two processes. Now, at that beginning of the run, when you are struggling to breathe, because oxygen is needed to make ATP, and you started running, you decreased the oxygen to your cell, making it work anaerobically. So therefore, you placed your body into oxygen debt. Okay? But once you hit your stride, okay, into the run, and you hit your stride, about 3 minutes into the run, okay, your body can now go back to making ATP aerobically. But your body is still in oxygen debt. And it will remain so depending upon the exercise that you do and how strenuous it was. It can remain in oxygen debt for up to 24 hours or more. Meaning your body is spending the rest of that time trying to recover the oxygen that it lost, trying to give you what you needed to do the exercise. The way that your body wants to supply the fuel, the ATP, the first thing it wants to do, it wants to use the glucose molecule or the fatty acids. Alright? So if it uses the fuels at first, okay, glucose, fatty acids, the body is still aerobic respiration. But once you leave using those materials and you start into creatine phosphate, it's going to go into anaerobic respiration, send your body to oxygen debt, and you're going to have to pay that debt back to the body, which is kind of cool if you think about it. People do it every day. Every day. Take a break. Be back in 3:30.